Hey everyone, Jerry here from LlamaIndex, and today we'll be going through a cookbook showing you how to use Claude 3 in your LLM applications. So Claude 3 just came out 2 days ago on Monday, March 4th, 2024, and it is probably the best set of models out there today, especially Claude Opus. And so Anthropic released three new models. There's Claude 3 Haiku, Claude 3 Sonnet, and Claude 3 Opus. And Opus is by far the best model and pretty much outperforms all other models, including GPT-4, on a variety of different benchmarks. You see this here in terms of numbers, but you also see it in terms of people personally playing around with Claude on Twitter. And by all means, all the results seem quite impressive. Also, Claude has a 200,000 context window. And they said they'll extend it to 1 million soon, but right now, in terms of what users can use, it's 200K. The other piece here is that Claude 3 is accessible via API, and of course, you can also subscribe to Claude Pro to get access to Opus. By default, the chat UI is Claude 3 Sonnet. So we've been playing around with it actually, and it is indeed quite impressive. And the goal of this is to really just show you a notebook of how all the different use cases you can plug Claude 3 into, from basic RAG to text-to-SQL to agents. And we'll walk through how you can use Claude within LlamaIndex. So let's go through the Claude 3 cookbook. To start with, you're just going to want to pip install the LlamaIndex Python library. Anthropic doesn't natively offer embedding models, and so in this case, we're just going to use an off-the-shelf Hugging Face BGE embedding model for any sort of RAG setup. We're also going to load in a simple article from the web just for data indexing. This is like a toy article. And to use Anthropic, you're going to want to install the LlamaIndex-LLMs-Anthropic package. This allows you to pip install our integration and then directly use the wrapper and integrate this with the rest of our abstractions. So you run these pip installs, you get back the outputs. Just to save some time, we've already run it for you. The next piece is to load in some data. And so here, we just load in a simple article from The Verge. The title of this is "The Synthetic Social Network is Coming." And you can see it's a pretty short article. There's really not that much stuff in here. You can actually fit this entire thing easily within a context window and get back a reasonable response. But really, this is just to showcase how you can build something over a toy data set. We use the beautiful Soup web reader to load in this web page, and this is a nice reader that cleans out the HTML and formats the text for you. The next piece is to enter your Anthropic API key. Here we've already pre-entered it, but just make sure to do it when you follow this notebook. Now we get to the interesting stuff. So we want to import from LlamaIndex.LLMs.Anthropic, import Anthropic. This is the LlamaIndex wrapper that wraps the Anthropic client SDK and allows you to basically access all the underlying methods, including completion, chat, async, as well as streaming. You see, you just need to specify a model name and then optionally the temperature. Here we set the temperature equals a 0 just to enforce some determinism in the notebook runs. And then for the model, we're currently going to test with Opus. By default, actually by default, it's Claude 2, but you can also use Sonnet if you want. The next item here is to just define a settings object. And this is a convenience wrapper within LlamaIndex where you can basically define some configuration settings once instead of passing the LLM through all the other modules that we have. So you can just call settings.LLM equals the LLM that you defined here. And then the embedding model, you can actually, we have proper abstractions for embedding models. You can import the embedding modules and set the embedding model as follows. Here is actually just a string, and this is basically just some syntactic sugar. Instead of trying to import the module, just define a prefix. Here we define local, which means it's a local Hugging Face model. And then here is just the Hugging Face model ID. So here we just use the BAI BGE small models. So let's run this again. And then as a next step, we're going to create two indexes. One is a vector store index, which is a classic index on LlamaIndex that allows you to generate embeddings for all the chunks within your knowledge, the documents that you feed it, and then interact with it via top K retrieval. And then the summary index, which will just index everything by key value. And then during retrieval, it just returns everything. So it's basically a very simple index that just returns all the context that it has. So we'll first call the vector store index to basically build an index over these documents. The next step is to call summary index.from documents. Now, we just define some helpful imports for logging. Now that we've built the vector index, we can basically run our first RAG pipeline. The first thing we'll show is just a very basic RAG pipeline defined by vector index.asQueryEngine with response mode equals compact. A query engine here is just a retrieval query engine, which first runs retrieval and then runs response synthesis. And setting response mode equals compact means that during response synthesis, we retrieved a bunch of chunks, and so we're going to take these chunks and try to compact it as much as possible into the prompt window of an LLM. This is probably the default setting you should always use whenever you're using a query engine on top of an index. Once you get back a query engine, this is just an object you can call to ask any questions and get back a response. And so it'll just trigger the RAG pipeline run. Given that the contents of this article, we're going to ask, how do OpenAI and Meta differ on AI tools? Run this. So it's going to do embedding-based retrieval and then synthesis via Claude 3. It probably takes a little bit of time because the embedding model needs a little bit of time to run. But it's able to do it and then gives you back a response. Based on the information provided, OpenAI and Meta are taking somewhat different approaches. Of course, there's other response modes too. There's response mode equals refine, and then also response mode equals tree summarize. We won't really go into detail here, but if you want, you can check out the docs just to see how these response modes work. To go a little bit beyond the simple RAG pipeline, the next step here is to go over the router query engine. And here, what is a router? A router is basically just a simple module that, given a query and a set of choices, decides which choice that given query should be routed to. And so it will just call that choice and pass the query over to it. It's very simple. And in some of our other talks, we basically paint it as one of the simplest agent abstraction you can do because it uses an LLM for reasoning. It's basically just a prompt, and then it just does some basic dynamic choice selection and picking to route the query to. One of the use cases here is actually doing joint question answering and summarization. And so as an example here, we can basically define a vector tool, which is a wrapper around the query engine, which does the top K RAG setup. The other is a summary tool, which is a wrapper around the summary index query engine, which retrieves everything and can do summarization like queries over that data. So, given these two tools, as well as the metadata attached to each tool, we can now define a router over these choices. So let's first instantiate these. Both are defined as query engine tools, right? And each has a name and description. And as a next step, we'll define a router query engine. The router query engine just takes in both tools. And then, you can actually do multiple choice selection if you want, as in it can choose more than one choice. Here we only have two tools, so we set select multi to false. And then let's run a question over it. One interesting piece about Opus, which we tried, is if you just ask a question like what was mentioned about Meta, it actually ends up throwing an error in a router because it ends up not picking one of the two choices. So this is just a slight quirk we'll work out. But you can basically say, what was mentioned about Meta, use a tool, and then it will actually try using that tool to one of these two tools to answer the question. So let's run this. You see it takes just a little bit of time because it's using the model to, one, make a choice, and then two, do retrieval and synthesis. But we get back the final answer, right? And you see that, if you ask this question, what was mentioned about Meta, you see that it's able to give you back the answer. Meta is doing the following related to AI. If you take a look at the number of source nodes, response.source nodes, you see it's equal to 2. And this is basically the k-value set for top k retrieval for the vector query engine. So it's effectively picking the vector query engine. If you really want to see a verbose output, all you have to do is just toggle verbose equals true, and then you'll be able to see actually what choice it made in the log outputs. Okay, we're going to skip multi-selection for now, but actually let's go on to another advanced RAG concept, which is query decomposition. So this is what we call the sub-question query engine. And what it is it's a layer, again, on top of a set of tools that you define. And what it does is, given a question, it'll actually decompose that question into a set of sub-questions and decide what tools correspond to those sub-questions. In that sense, it's actually a little bit more complicated than routing, because routing takes the original question and chooses, the tool or subset of tools that I should route to. Now, the sub-question query engine also takes those questions and decomposes those questions into sub-questions, and also picks the tools relevant that are necessary to answer those sub-questions. So it does an extra step of query decomposition. And similarly as before, we define both the vector tool as well as the summary tool. So the vector tool is better for, again, answering specific questions, and summary tool is better for summarizing an entire document. We'll import an async IO because you'll see this actually just spins off sub-questions, launches separate async threads. And then we define the sub-question query engine and call sub-question query engine.from defaults. We call it with both of these tools. We set verbose equals to true so we can actually see the log outputs. And then let's ask the multi-part question. What was mentioned about Meta, and how does it differ from how OpenAI is talked about? As we're running this, you see it's running. And you see that, it actually generated 5 sub-questions. So, Opus is pretty eager about just trying to really break down that question into a bunch of things that could be answered by the different tools. First, one of the sub-questions is what was mentioned about Meta in the document. That's using vector search. One is the summary, is summarize the key points about how Meta is discussed in the document. So that's really, going through all the context, actually. Another is using vector search, what was mentioned about OpenAI in the document. And the summary tool is summarize the key points about how OpenAI is discussed in the document. And the last is compare and contrast the key differences and how they're discussed based on the summaries. You actually see all the questions are launched in parallel, and so you see the answers getting streamed back, maybe a little bit out of order, but all the answers are coming in from these different tool executions. And then at the end of the day, it combines all the responses and gives you back a final result. According to the article, it's taking a different approach to Gen AI compared to OpenAI. So again, this is another step towards an agent that can do query planning execution, and we'll actually see what a full React agent looks like later on. But this is basically a one-shot query decomposition question answering tool. The next item here is our SQL query engine, where we show how to connect to a structured database and run Text-to-SQL over it. And here, this is basically showing how you can use Claude 3 with our Text-to-SQL abstractions. So we'll download the Chinook, SQLite database. It's just a very popular test database containing information about music, artists, albums, and we'll ask some questions over it. We put all the data in SQLite and we connect to it via SQL Alchemy. So engine equals query engine. We then wrap it with our own SQL database abstraction, which then allows you to plug it into our NL SQL table query engine. So a slight mouthful, but basically it's our Text-to-SQL query engine. And the SQL table query engine takes in the SQL database along with the tables that you want to query over. And so you define this query engine, and then when you ask query engine.query, what are some of these albums, it's able to give you back a response. So it's running right now, and under the hood, what's happening is it's taking the natural language, translating it to SQL using the LLM, executing the SQL against the database, and giving you back the response. Oh, and there's another LLM call at the end to synthesize a final response for you. Let's actually go through and take a look at an example query. And so let's ask, what are some tracks from the artist AC/DC, and limit it to 3. And in this example, we'll actually be able to see the SQL query that's created. So first we'll run it. Just going to hide this for now. Okay, and it generated an answer, and then we can see the SQL query under the hood. So select tracks.name, title, Llama. The next application use case is structured data extraction. This is a very popular use case with LLMs these days. And also, more and more LLMs are actually coming out with init support for function calling. So it started with OpenAI. Claude 3 actually has inbuilt support for function calling as well. But one of the things here is, we're actually still working on function calling support for Claude 3. And, in general, for any LLM, even if they don't support function calling, you can prompt the LLM to try to output correct JSON. So in this setting, we have what we call programs within LlamaIndex, which is our main abstraction for structured data extraction. It's basically combining a prompt LLM as well as your desired output format in a Pydantic schema. And you can, basically, you can plug in any LLM into it and try to generate an answer that conforms to that schema. Of course, certain models will work better than others. The LLM text completion program relies on direct prompting. We also have a Pydantic program that integrates with, for instance, OpenAI function calling, and we're working on an integration with Claude as well. So in this setting, we're using LLM text completion program. And then, we will define the desired Pydantic schema, which is song as well as album. So song contains both title as well as the length in seconds, and then the album is name, artist, and a list of songs. So you can see it's actually, album contains a list of songs, so there's some sort of nesting going on. What you can do is, after you define these Pydantic classes, you just import our LLM text completion program, and you just call it .from defaults, and you pass in 3 things. One is you pass in the desired output format, which is our album class schema. You pass in the prompt template string, which is the input that you want to feed to the LLM. You pass in the LLM itself. So first, let's run this, and then let's run this. And the input to this program is basically all the free template variables that exist in the prompt template string. So here you see, use the movie name as inspiration. This means this is the input string that you want to fill in. So if you call program movie name equals The Shining, it'll generate an example album that's inspired from The Shining. You see it's complete, and then the final output looks like this. You have Overlook Hotel, the artist, and a list of songs. You see that the type of the output is actually just the album class defined here. And the output representation, correctly contains the name artist and actually extracts out a set of songs as well. Last but not least, we'll set up a React agent with Anthropic Claude 3. Similarly to the structured data extraction example, the React agent just relies on direct prompting for the LLM. So we don't really integrate with the function calling yet. And so actually an agent that directly leverages function calling to help make the next decisions is something that is upcoming and coming up soon. But the React agent is a general purpose agent that basically takes in any LLM and tries to prompt the LLM into outputting, given a set of tools, the actions, right, to take in order to solve the issue or in order to solve the task. So the React agent takes in an input set of tools. We'll use the tools that we defined above, vector tool and summary tool. Again, vector tool is for question answering, summary tool is for summarization. we pass in the Anthropic Claude 3 LLM, and we initialize the agent. Now we can chat with the agent. So we can do agent.chat. It will maintain the conversation history over time. And if we just say hello, it won't use the tool, right? It will just give you back the response. The React agent, of course, uses the React framework, which is just chain of thought reasoning combined with tool use. So given a question, it'll break it down step by step, and then within each step, it'll decide to call a tool or to finish execution. So here is hello, how can I assist you today? And then the next one is, let's ask the exact same question we asked the sub-question query engine. What was mentioned about meta? How does it differ from OpenAI? And this is basically a multi-part question, and let's see how the agent is able to answer this question. You see that it's going through the chain of thought loop right now. First, it says to answer this question, I will need to search the provided documents for mentions of how meta and OpenAI and how they are discussed differently. So the first is vector search on meta. So it's processing that. And of course, the vector RAG pipeline gives you back an answer. And then given this, you generate the next thought, which is it provides useful information, but you still haven't searched OpenAI yet. And so you need to search mentions of OpenAI. So you do vector search input equals OpenAI. You get back another observation about after running the vector tool on OpenAI. And after this, in the conversation history, it sees that it has both meta and OpenAI. And then when you pass it to an LLM, it will be able to give you back the final response. Great. And so, the final thought is that, I have all this information, and so therefore I am done. And so this is the final answer that you get. There's, of course, more interesting agent approaches out there, everything from plan and solve, like basically doing some sort of query planning, like the sub-question query engine, but doing it in a loop. There's being able to do some sort of like async parallel function calling execution, like LLM compiler. There's doing stuff around like Monte Carlo tree search, and a lot more stuff to come. But hope this was a general overview of how to use Claude in a variety of different use cases. And we'll do a more in-depth deep dive into a lot of this, especially just to better explore the capabilities of Claude. But in any case, thanks, and feel free to leave your comments below, and see you guys soon.